All right, second to last lecture for Science 101. We're going to do cylinder duration, different types, whether it's gas, liquid, measured by volume or weight. All right, helium-oxygen flow rate conversion. So what's heavier, helium or oxygen? Helium's heavier? What do we fill blimps with? Helium, right? So helium has an atomic mass of 4, where oxygen O2 is like 32 grams. So definitely helium is a lot lighter. So sometimes we'll use a helium-oxygen mixture. However, since it's replacing mostly nitrogen that's in the air, right? It's 80% nitrogen in our atmosphere. So we're changing something that is 28 grams per mole out with helium, which is a lot lighter. So the gauge that we use, right, the pressure gauge that we use is set for regular air or oxygen, right? So it's either an O2 sensor or an air sensor. So it's not designed to handle helium-oxygen mixture, but we have a convenient conversion factor based on the ratio. So if we have an 80-20 mixture, all you have to do is multiply by 1.8, and that'll give you the actual flow rate. Because the gauge is for oxygen. What we're using is helioxygen, right? So the gauge is not the exact one, but all we have to do is multiply by the factor. So a 70-30 mixture, multiply by 1.6. All right, so we got 10 liters. The gauge is reading 10 liters, right? So this is what the gauge is reading. The oxygen gauge is reading 10. We're using 80-20 mixture. What are we actually delivering? So you take the flow rate, which is 10 liters, and you multiply by the rate. In this case, it is 1.8. So your actual flow rate is how much? Yeah. So the gauge read 10, but you got to know you're actually delivering 18 because you're using helium. If it is a 70-30 mixture and the gauge reads 10 liters, you're actually delivering what volume? 16. Right? So just remember the ratio, 1.8 for 80-20. So that's probably easy, 8 with 8. And then if it's a 70-30 mixture, the conversion factor is 1.6. All right, I'll have you guys do C and D. All right, what'd you get for C? All right, 14.4. How about D? All right, so that's it. Just remember, because helium's a lot lighter, you're actually going to be delivering more because we're using an oxygen gauge, not a helium-oxygen gauge. H and K cylinders. So there is a minimum level that you don't want to use these cylinders, but we're just going to ignore that for this course. So we're going to assume everything's ideal. You can use every last drop of air. Plug and chug, that's all we're doing. So for H and K cylinders, you're going to multiply whatever the reading is on the gauge right? Pounds per square inch. G is the gauge, whatever the gauge is reading. So pounds per square inch off the gauge times 3.4 divided by the flow rate. And that'll give you how long in minutes it'll last. Right? So the gauge is reading 1,000 pounds per square inch. Some of these numbers are made up as well. Right? So we're going to assume that we can use every last drop inside these cylinders for this course. So all you have to do is plug and chug. So let's take a look at A. Do 3.14 times the gauge reading, and you just divide it by the flow rate. So here we are delivering 5 liters per minute. So 3.4 liters per pound per square inch gauge, so that's our conversion factor, gives us about 3,140 divided by 5. What does that give you?
628.
How many minutes? 628 minutes. So you can round to the nearest minute. B, same thing. The conversion factor is 3.14 liters. We're assuming perfect conditions here. And this time the gauge is reading 1,250 pounds per square inch. And we are delivering 6 liters. So for B, how long, theoretically, will the cylinder last? You got 654? All right, we got a couple.
64.16. You want just 654?
Yeah, round to the nearest minute. All right, same for C, 3.14. This time our gauge is reading 2,200 pounds per square inch. And we're delivering 4 liters per minute. $1,727. 727, right? That's it. And then if you need to convert to hours, just divide by 60. All right. So this time, the doctor wants you to notify him once the gauge goes down to 200. So what is the gauge for D reading right now? Right now it's reading 15. When do we want to stop? At 200. So what are we actually going to use? 200? So here's the gauge. It goes from 0 to 2,000. There you go. So 0 is empty. We are at 1,500, but we're only going to use it up to 200. Right? So how much are we actually using? 13, right? So take the gauge currently, and we want it to go down to 200. Don't go past, don't go lower than 200. So let me know, when should I come back to check? So we're going to use 1,300 pounds per square inch. So for D, instead of using the full gauge reading, we're just going to take the difference. 3.14 times 1,300 pounds per square inch that we're using. And this time we're delivering 3 liters per minute. So how long until it gets to 200?
1,360.
All right, not bad. So most of the day, about 20 hours, 20, 22, 23 hours, we'll be fine. So a whole day. All right, so that was H and K cylinders.
I got lost on that one.
On this, okay, so the gauge is reading 500 currently, so this is now. but we're not going to use it all the way down to 0. Right? We're not going to deplete this cylinder. We're only going to use it to 200, so we have to stop at 200. Oops, stop. So what are we actually using? Well, the gauge is at 15, but we're going to use it till 200, so we're actually using 13. Right? So it's just the difference.
So we just set up the equation as 13 for the.
Yeah, because we're only going to be using 1,300 pounds per square inch. So the gauge is at 1,500. We're going to let it run down, but the gauge needs to stop at 200. All right, so keep that in mind. We'll do a lot of these. Stop at a particular pressure or weight. E-cylinders. Again, we're just going to assume perfect conditions. This time the conversion factor is 0.28. So the math is exactly the same. So for A, we take the conversion factor, 0.28, multiply by the gauge reading, which is 2,000, and divide by the flow rate, which is 4 liters per minute. So for A, how long would A last? 400 even? All right, not bad. 400 minutes. B and C. So we're not going to deplete the entire cylinder for B and C. So B, we're starting at 18. We want to stop at 2,500. So let's find the difference. So the difference is 1,550. And then we just plug and chug. 0.28 times the amount of pressure we're going to use, 1,550, divided by the rate. In this case, it is 6 liters per hour.
If you round it up, it's going to be 180.
About 180?
Yeah.
180 mLs?
Yeah, it says 179.8.
Okay, yeah. So 180 for B. Moving on to C, we're starting at 1750. I want you to stop at 100. So we are going to be using 1,650 pounds per square inch. Just plug it in. For E cylinders, the conversion is 0.28 liters per square inch of pressure. Our rate here is 5 liters. How long until 100 pounds per square inch? All right, so about 92 minutes. Liquid oxygen. So we can measure it by volume or we can measure it by weight. So the conversion factors are given to you. If you are measuring it by weight, if you take that cylinder empty and filled, the difference will be how much liquid oxygen you have. So for every pound of liquid oxygen, that's going to convert to 344 liters of gas. Or by volume. So this is volume of liquid oxygen. So 1 liter of liquid oxygen will yield 860 liters of gaseous oxygen. So those are your 2 conversion factors. So based on what's given to you, you'll know which factor to use. So if you're given pounds, right, you got 2 pounds of liquid oxygen, same equation. This time our conversion factor is 344 liters, right, per pound. So we got 2 pounds for A, And our flow is 4, and that's it. 344 times 2 divided by 4. 172, yeah, 172 even. All right, B.
I did like 5.
Oh, okay. You mix these up. Be careful. All right, B, same way. Our conversion factor is 344 liters per pound. We have 3 pounds of liquid oxygen, and we're delivering 5 liters for this guy. Two, how much? 206. All right, 206 about. All right, so that's A and B, straightforward. We're going to assume that we can deplete the entire cylinder and the oxygen stays as liquid. All right, this time, similar to the previous, we're not going to deplete the entire cylinder. So we're starting at 5 pounds. Let me know when it reached half a pound so I can change it out. So we're actually going to use 4.5 pounds. So for C, conversion factor times the actual amount of oxygen we're going to use, 4.5 pounds, divided by the rate, in this case it's 3. How much? 500? 516. There you go. So that is if you were given weight in pounds of liquid oxygen cylinders. Now we're going to do the other half where you're given volume. And we're just going to use the gauge, right? So different size containers. So for A, the container is 2 liters. That's all it is, a little tiny 2-liter bottle. And the gauge on it just tells you if it is full, 3/4 full, half full. So it's an arbitrary gauge. Right? So we can just assume that's the fraction of the container. So in this case, A and B, we're going to assume we're going to use the entire container. So we got 2 liters of liquid oxygen. So our conversion factor is 860. So for A, we're going to assume that this container is full. Right? The entire 2 liters, it's completely full of liquid oxygen. So the capacity is 2 liters, and the conversion factor is 860. And you just divide that by the rate, which is 5. So here the gauge is full. So one full gauge is 1/1, which is just 1. Right? So we just ignore that factor.
Unless it's added in.
Added in?
Unless there's
Yeah.
calculation for it.
Yeah, so it didn't give you any information for how much of that container is left. So it's just one full container. All right, so 2 liters times 860 divided by 5. How many minutes would that last? About 344, right? A little bit over 5 hours, almost 6 hours. All right, this time we got a little tiny container, 0.8 liters worth. For every liter we get 860, and this time we're delivering a rate of 3 liters per minute. Six, half of 6, yeah, 3 something. 3, 229, 229. All right, so we're assuming these are full containers, and we're using it down to the rest. This time the gauge will come into effect. So again, the gauge is just an arbitrary gauge. It's just saying, hey, this container is 1/3 full right now. So the capacity is 1.6. The conversion factor is the same, 860, but this time you have to multiply by what the gauge is reading. So we got 1.6 liters. Conversion rate is still the same, 860 for liquid, but this time it's only a third full. So we can only multiply by a third, and our rate is 4.
Could you use 0.33 as a third?
Yeah, it's the same thing. Remember fractions, decimal percentages?
You said that you put 1.6 times 860 times 1 divided by 3.
Yep, divided by 4. Dun dun dun. What do you get? Yeah, about 114. So that's like 113.5 or 6. So round up. All right. So make sure you're able to punch that in. The only thing difference between C and the previous is the gauge. So for D, just set it up the same way. Our container is 1.2 liters. The conversion factor is 860 liters of gas per liquid, and our gauge is reading 3/4. We are delivering, yeah, you can use 0.75. Fractions, decimal percentages. How many?
387.
387? I got a second, got a third?
Or it's 387.
So just do 1.2 times 860 times 3 divided by 4 divided by 2. All right, that's liquid oxygen. If you're given weight, your conversion factor is 344. If you're given volume, your conversion factor is 860. All right, that's it. Not too bad. Let's get started on the homework.